Hey guys, welcome to another video series. So today we're going to do number 70, which is climbing stairs. It's a very known pattern for recursion. It's also a dynamic programming problem since we have a lot of repeated work. But I will very quickly just read the description. So you are climbing a staircase. It takes n steps to reach the top. Each time you can climb one or two steps, and how many distinct ways can you climb to the top, right? So we have the first example where if n equals to 2, the output is 2. And the output is 2 because there are two ways to climb. We can do one step plus one step, or we can do two steps. Example 3, if we have n equals to 3, we have the output of 3 because there are three ways of reaching the third step. So we can go one step plus one step plus one step, one step plus two steps, or two steps plus one step. So we can very quickly see that it doesn't matter. I mean, if we have different orders, there's still different ways of reaching the top, right? So 1 plus 2 is not the same as 2 plus 1, right? Because okay, cool. I hope you guys understand. So when thinking about sort of recursively, we know that, I mean, if we have a tree, right, I always recommend that you guys make a graph in the interview. So let's say n equals to 2, right? Let's say n equals to 2. So if we're creating a tree here, we know that we only have two choices. We can climb one step, or we can climb two steps, right? So if we do 2 minus 1, we know it's 1. So there's another level that we need to go, right? So now if we do 2 minus 1 is 1, 1 minus 1 is 0. So we found an answer. Now, if we have 2 over here, if we do 2 minus 1, we'll have 1. And then if we do 1 minus 2, we'll have a negative number. And that's not what we want. So I will remove this. Also, now if we do 2 minus 2, we have 0. So we also found an answer here. So there are two ways to reach n equals to 2. Right? So we have 1 plus 1, and then we have two steps. So I guess now we just need to write this in code. And it's very, very simple if you guys know recursion. So we always start with a base case, and then we have a recursion case. And then in our base case, just follow along. Hopefully you guys will understand. So we're going to say if n equals to 0, then we return 1, right? So if we look at line 15, right, we have 2, and then we do 2 minus 1 is 1, right? 1 minus 1 equals to 0. So once it equals to 0, we know that we found an answer. Therefore, we return 1. And then we also have another answer, which is 2 minus 2 equals to 0. So we also add 1. Therefore, it becomes 2. Okay, cool. Hope you guys understand that part. So now we just need one more if statement in cases in case we have a negative number. So for example here, if we have, let's say 2, this would be negative 1. So that's not what we want. So if we're going to say if n is larger than 0, right? Or we can just do it like this. If n is larger than 0, then we know that we need to return 0, right? We don't do anything, we return 0 because there's nothing to return. So now we just need to do the sort of Fibonacci pattern where we just add the last two steps, right? So we do climbing stairs n minus 1 plus climbing stairs n minus 2. And this here should give us our answer. Let's run the code. Oops. Let's see. sorry, if 0 is bigger than n. There you go. Okay, cool. So this is our answer. The problem is if we submit, it's going to be very slow because we're doing a lot of calculations. It's very inefficient. So we need to make it more efficient, right? We need to cache our answers so it can be pre-processed in terms of we're not making the same calculations in terms of subtrees, right? And this would save us a lot of time. So once again, this is the top-down approach. And if we want to cache, we just need to use something called memo, which is pretty much the same thing. So we can create an object. And once we do that, all we have to do is we just need to say if if n in memo, right? So we just need to check if our number is inside of the object memo, then we just return the memo at n, right? So we just need to return the value inside of the memo object. So now, since we have a second parameter of memo, we just need to add it to our answer. And we need to do memo at n equals to everything in here. And then in the end, we just return memo at n. So let's run the code once again. It runs. Let's submit. It should work. I mean, this is a much better approach. So this approach makes our answer O of n in terms of time, since everything's memoized, and then O of n in terms of space, as opposed to our previous answer without the memo, which is 2 to the power of n, which is very, very expensive. And the reason why it's 2 to the power of n is because we have 2 to the power of n nodes in our tree. And then in terms of space, it's the same thing. It's O of n, right? We're just using the stack. But this is the answer that we want. Okay, so now let's look at the answer that I believe most people would use in an interview, which is the bottom-up approach. Okay, so for the bottom-up approach, I mean, I would say the logic is very similar to the recursion. That's the reason why I did it first. But for the bottom-up, it's a little bit different, just in terms of the thought process. So essentially what we want to do is we want to calculate in a table every answer until we get to our final answer, which should be the last item in a table. I think it's going to be a lot easier if I just code first and then explain. So like most dynamic programming, we just need to create a table. Oops. Okay, so we need to create a table, or you can call it DP, and that's essentially just creating an array that we need to fill with zeros. So we're just going to say, we're going to say n plus 1, and then we're going to say fill zeros. Okay, cool. So what we have is we have an array with n plus 1. So if n equals to 2, then the array is going to be 0, 0, and then 0. Cool. So that's the first step. And then now we need to sort of add the starting point of our table, the calculated numbers. So we can say something like n table at 1 equals to 1, and then table at 2 equals to 2. So these are the steps that we can take. So we know that table at 1 is going to be step 1, and then table at 2 is going to be step 2. So that's already pre-calculated. So now it's very easy. This part now, we just need a loop. So we're going to say I equals to 3 because the first index and second index are already calculated, and then we say n equals to or is less than if I is equal to or bigger than n, and then we just increment. So the logic here, it's kind of like I said, very similar to the recursion. So now we're going to do table at I equals to table at I minus 1 plus table at I minus 2. Cool. And then lastly, we just return the table at n, right? N is the last index in the table. So in this case, if we're doing if n equals to 2, we're just we're pre-calculating. We're already adding 1 and 2 to the table. We come to the loop. We don't really run the loop because the loop only runs if I equals to 3 or is bigger than 3. As we see here, our table only has up to index 2. So we just go to line 16 and then we just return table at 2, which is 2. And let's submit. It should work. Okay, we're getting an error here. Let's see. Okay, I'm missing a 2 over here. Table at I plus table at I equals to 2. Return table. No, if n is bigger or equal to I. There you go. Okay, cool. So we have our answer over here. If n is bigger or equal to I. Yeah, guys, so this is our final answer in the bottom-up approach. I think this should be the most used approach. In terms of time and space complexity, we're really talking O of n for time and O of n for space. Since we're not really doing anything else, I mean, as far as space, we're just creating a table, and then as far as time, we're just looping. That's in the worst case. I mean, if n equals to 2, in terms of time complexity, it could actually be constant since we're not even going through a loop. But yeah, in the worst case, we have linear time since we have to compute in our table. So hope you guys enjoyed this. I'll see you in the next one. I mean, please comment if you have any questions. Don't forget to subscribe, and I'll see you guys in the next one.